Welcome to the video on functions, domain, range, graphs, and inverses. Functions are written as f of x. So f is a function of x. So functions are mathematical models that describe the relationship between variables. Function notation, f of x, is f as a function of x, where x is the input and f of x is the output. So here for this example, we have c of x. So this is still function notation. You can use different letters, but it's something on the outside and then you have your input inside parentheses. So c of x equals 2x squared minus 3x plus 4. So it says find c of 2. So if it's in the parentheses, this 2 is replacing x. So our x equals 2. So c of 2 equals 2 times 2 squared minus 3 times 2 plus 4. So 2 times 2 squared is 2 times 4, which is 8, minus 3 times 2, so minus 6, plus 4. 8 minus 6 is 2, plus 4 is 6. So c of 2 equals 6. Next we have find c of x equals 24. So for this one, we want the output to be 24. So you would say 24 equals 2x squared minus 3x plus 4. So we need to solve for x. So we'll start by subtracting 24 from each side. So we get 0 equals 2x squared minus 3x. And then 4 minus 24 is a negative 20. So we'll want to factor this. So I like to use the box method to factor. In the top left corner, we'll write our 2x squared, our a value. And in the bottom right corner, we'll write our c value, negative 20. So we need to find something that multiplies to 2 times negative 20. So it needs to multiply to negative 40, and it needs to add to our b value, so negative 3. So 5 and 8 will multiply to 40. We need it to add to negative 3, so we're going to have a negative 8 and a positive 5. So we'll put negative 8x and 5x in here, and then we'll pull out our greatest common factors. So 2x squared and negative 8x, our greatest common factor is 2x. Between 5x and negative 20, our greatest common factor is 5. Here on our columns, our greatest common factor between 2x squared and 5x is just x. And then our greatest common factor between negative 8x and negative 20 is negative 4. And you'll pull the negative out if the one closest to the arrow is negative. So in this case, this one's negative, and this one we won't pull out a negative because our 5x is positive. So it factors to x minus 4 times 2x plus 5. So we want to find when that equals 0. So if this is 0, then 0 times something will be 0. Or if this is 0, 0 times the other thing would still be 0. So we want to find when x minus 4 equals 0, or when 2x plus 5 equals 0. So if we add 4 to each side, we get that x equals 4. And here we'll subtract 5 from each side. We get 2x equals negative 5. And then we'll divide by 2 and get that x equals negative 5 halves. So c of x equals 24 when x equals 4 or negative 5 halves. Next, we'll learn about domain and range. So domain is the x values where the function exists, and range is the y values where the function exists. So we'll start with our first one here. So this one, our line seems to go on forever. So if we look along the x-axis, it's going to exist for all values of x in both directions. So our domain is going to be from negative infinity to infinity. And you'll put parentheses around the infinities because you can't actually hit the number infinity because it's not actually a number. So we'll put parentheses is the number is not included. And we'll use brackets if the number is included. So for this first one, our range, we'll look along the y values. So these are going to be hitting all of our y values forever and ever. So it's going to go from negative infinity to infinity. For the second one, it starts at -4 along our x-axis and then goes forever to infinity. So our domain is going to be from -4, and -4 is included because we have a point there. So -4 to infinity. And then we have the parentheses around the infinity again. For our range, we're starting at -1 and going up. And this is going to keep going up, even though it's by a small amount. It goes up. So it's going to be from -1 included to infinity. For this final one, it's a little bit more complicated. So we have our domain is our x values. So it's going to exist for all x values up until 0. It doesn't exist at 0. So we'd have negative infinity to 0, and 0 is not included because we don't have a point at 0. And then we have a second section of our function, so we're going to put a u for union, and then it starts just after 0 and goes all the way to infinity. So u, 0, comma, infinity. And then for our range, our y values go from negative infinity all the way up to about -3. So we'll say negative infinity to -3, and we'll include that because it hits the point in the union, and we start again at 3, and we go up to infinity. So 3 included, comma, infinity. So that's our domain and range. Then we have inverse functions. So those are written as f to the -1, so that's your inverse of x. So an inverse function reverses or undoes a function, and it reflects it across the line y equals x. An inverse function only exists for one-to-one functions, so functions where the outputs are not repeated. So if you had an x² function, this is not a one-to-one function, because if you look along your y value here, you have 2 different points. So if you wanted to do an inverse, you'd have to restrict your domain to just being x is greater than 0, because then you would just have this part, and you would only have one output for each input and one input for each output. Your domain and range of a function are going to be swapped for your inverse, so the domain will become the range and the range will become the domain. So your f of x equals 10 is the same as f inverse of 10. Because in this first one, 10 would be your output, your y value. And in the second one, it would be your input, your x value. So your y and your x are swapped. So to find the inverse of a function, you swap your x and your y in the original function and then solve for y. So if you had the function y equals 3x plus 2, to find your inverse, you would say x equals 3y plus 2, and then we'd solve for y by subtracting 2, so x minus 2 equals 3y, and then dividing by 3. So y equals x minus 2 over 3. So this would be your inverse, and this would be your original function. And to prove that it's the inverse, you could take your inverse function and plug it in for x in the original function. So y equals 3 times, we'll put our inverse in there, x minus 2 over 3 plus 2. Our 3's would simplify and become 1's, and then you have y equals x minus 2 plus 2. Minus 2 plus 2 is 0, so y equals x. So that proves that your second one was an inverse of your first one. So for practice, we have a problem here that says the Hong Kong dollar is approximately 7.85 times the US dollar. Write an equation, h of u, to find the worth of 13 US dollars in Hong Kong dollars. So we have H of U, and it says the Hong Kong dollar is 7.85 times the US dollar. So to figure out that, we would do 7.85 times our US dollar. So if we want to know the worth of 13 US dollars in Hong Kong dollars, we'd plug in 13 for U. So H of 13 equals 7.85 times 13. 7.85 times 13 would be 5, carrier 1, 24 plus 1, 25, carrier 2, 21 plus 2 is 23. Then we'll do our next row, 0, 5, 8, 7. And when we add those, we get 5, 0, carrier 1. 3 plus 8 is 11, plus 1 is 12, carry another 1. 1 plus 2 is 3, plus 7 is 10. And then we need to move our decimal over twice. So our answer would be H of 13 equals 102.05. So 13 US dollars equals 102.05 Hong Kong dollars. So now we need to find H inverse of U and describe what it means, and then prove that the function we found is actually the inverse. So to find our inverse, we'll swap our variables. So we have U equals 7.85 H of U. So we'll divide both sides by 7.85. So we get H of U, H inverse of U, equals 1 over 7.85 U. So with our H inverse of U, what we've actually done is we've swapped our variables so we can figure out US dollars from Hong Kong dollars. So really it's going to be like U of H equals 1 over 7.85 H. So if we plugged in 102.05 for H, then we would also be able to find that U equals 13. So our H inverse of U is our U of H, and it finds US dollars from Hong Kong dollars. And to prove that it's actually the inverse, we can take our original function, 7.85 U equals H of U, and we'll plug our inverse in. So H of U equals 7.85 times our inverse. So 1 over 7.85 U. The 1 over 7.85 simplifies to 1, so H of U equals U. So this is, in fact, our inverse. So now we have our first IB practice question. It says f of x is the square root of x minus 4. Find f inverse of x. So to find the inverse, we'll swap our x and y. So we have x equals the square root of y minus 4. To get rid of the square root, we're going to square both sides. So we have x squared equals y minus 4. And then we'll add 4 to each side. So x squared plus 4 equals y. Because x minus 4 is in a square root, it needs to be greater than or equal to 0. Because if you took the square root of a negative number, it would become imaginary. So x minus 4 has to be greater than or equal to 0. So we'd add 4 to each side. So our domain is restricted to x being greater than or equal to 4. So our f inverse of x equals x squared plus 4, where x is greater than or equal to 4. And we can double check that by plugging it into our original. So we have the square root of x, which we're going to plug in our inverse, so x squared plus 4 minus 4 equals y. So we have the square root of x squared plus 4 minus 4 equals y. Our plus 4 and minus 4 becomes 0, so we have the square root of x squared equals y. and the square root of x squared is x. So x equals y. So we have confirmed that it is the inverse. Here for our second IB practice question, it says, to the right is the graph of g of x. Find g of negative 4, g of 2, and g of x equals 4. Then graph g inverse of x. So g of negative 4, g of 2, and g of x equals 4. So g of negative 4 will go to where x is negative 4. So when x is negative 4, our y value is negative 3. So g of negative 4 equals negative 3. For g of 2, we'll go to our positive 2, and then we'll figure out what our output is. So that's 6, so g of 2 is 6. And then we want to find when g of x equals 4. So this means our output is 4. So we'll go to where y is 4, go over to our function, and then our input value was x equals 1. So that's our solution for that one. So now we need to graph g inverse of x. What we could do is draw a line at y equals x and reflect our graph over that. Or you can find points and then flip your x and y values. So we have a point here at 0, 2. So for our g inverse of x, it's going to be 2, 0. So 2, 0 right here. We have another point at negative 1, 0. So that'll become 0, negative 1. So 0, negative 1. We have a point at negative 3, negative 2. And that will become negative 2, negative 3. So it'll go right here. So our 0, negative 1 is where the graph changes slope. So now we can kind of follow the slope where we were. And then this one will be up 1 over 2. So your slope for this red section of the original g of x is up 1 over 1. And your slope's going to be the same, up 1 over 1. Because if you find the reciprocal of that, it's still 1 over 1. For our blue section, it was up 2 over 1. So our reciprocal for the new one is going to be up 1 over 2. So we go up 1 over 2. So this is your g inverse of x. So in summary, functions are mathematical models that show the relation between an input x and an output f of x. The domain is the x values where the function exists, and the range is the y value where the function exists. Inverse functions, or f inverse of x, are used to undo a function by reflecting the function across the line y equals x. They only exist for one-to-one functions, functions where the outputs are not repeated, and the domain and range of the function are swapped for its inverse. To find the inverse, you swap x and y in the original function and then solve for y. That's all for this video. Thank you for watching.